problem from area of a plane curve, and this problem consists three parts. In the first problem, it is given curve and we have to show that the area of the whole curve is this, and in similar second and third problem also. We first solve the first problem. From the equation of the curve, it is clear that if we put minus y in place of y, then the curve remains same. Okay, so the curve is symmetric about y, this is equal to 0, that is x-axis. Okay, now if we put y this is equal to 0 in this curve, then we get two value of x. One value is 0 and another value is 2a. Now we try to draw a rough sketch of this curve. This is x-axis and this is y-axis. It is 0, 0, 0, and this is 2a, 0. And since x equal to 0 and x equal to 2a are the point of intersection of the curve with the x-axis, so meet the curve at 0 and at a, right? This is the origin, so it be a. If we put here the value of x greater than 2a, then it is clear that this is negative, but the left side is a perfect square. So perfect square is not a negative quantity, so there is no curve in the right side of 2a or right side of the point A. If we put any negative value of x, then right side is also negative. So this is not satisfied by the left side. So there is no portion of the curve left side of the origin. So the only portion of the curve lies between 0 and 2a. Okay, and since this is symmetric about x-axis, so the curve have a loop in between 0 and a, that is O and a. Okay, and the curve is look like this. Now we have to find out the area, total area. So we first find out the area of the upper portion and multiply it by 2, then we get the whole area of the curve. Okay, so whole area is given by 2 into integration x equal to 0 to 2a y dx. What is y? Y is given by the curve. So we get 2 into integration 0 to 2a. Y is given by, this is root of this, so 1 by a into x root x into 2a minus x dx. Okay, so we get 2 by a into integration 0 to 2a x into root under 2ax minus x square dx, and getting the value as 2 by a integration 0 to 2a x into root under, we taking common here x square minus 2ax plus a square minus a square dx, and 2 by a into integration 0 to 2a x into root under a square minus x minus a whole square dx. Okay, now here we put x minus a, this is equal to sin theta, sorry, this is a sin theta we put, then we get dx, this is equal to a cos theta d theta, and putting the value of dx and x minus a here, also we first change the sign from x to theta. X equal to 0, x equal to 2a. The x equal to 0 gives the value is theta equal to minus pi by 2, and x equal to 2a gives theta equal to pi by 2. Okay, so our area is 2 by a into integration 0 to 2a, sorry, this is minus pi by 2 to pi by 2, and this value is given by a plus a sin theta, and from under root we get this is a square minus a square sin square theta into a cos theta d theta. Okay, so 2 by a into minus pi by 2 to pi by 2, we get a into 1 plus sin theta, into from here we get cos theta, and from here we get cos theta also, so this is a square cos square theta d theta, and a cancel out, so we get the value is 2a square into integration minus pi by 2 to pi by 2. The first integration is cos square theta d theta, and the second integration is 2a square into integration minus pi by 2 to pi by 2. This is cos square theta sin theta d theta. Okay, clearly this integrand is odd function, and we know that if fx is odd function, then we get minus pi by 2 to pi by 2 f theta d theta equal to 0 if f of minus theta, this is equal to minus f theta, that is odd function. And also we get this is 2 into integration 0 to pi by 2 f theta d theta if f of minus theta, this is equal to f theta, that is if it is even function. So from here we get this integration becomes 0, and this integration is equal to, we write here, this is equal to 4 square, from here 4 square into integration 0 to pi by 2 into cos square theta d theta plus 0. Okay, and we put 2 square into integration 0 to pi by 2, the formula of 2 cos pi theta, this is 1 plus cos 2 theta d theta, that is 2 square into theta plus sin 2 theta by 2, this is 0 to pi by 2. So we get 2 square into pi by 2, right, and this is equal to 0. So we get the value of the curve or whole curve is given by 2 to cancel out pi square. Okay, and this is our first answer. Right, now we go to the second problem. For the second problem, if we try to draw a rough sketch of this curve, here we first put minus y in place of y, then we say that it is symmetric about y equal to 0 because there is no change in the curve if we put minus y in place of y. Okay, similarly if we put minus x in place of x and this is the same as y, so it is also symmetric about x equal to 0, that is about x axis and that is about y axis. Okay, this is the first property. And if we put y this is equal to 0, we get from the curve x equal to 0 and x equal to plus minus a. So we get 3 points of intersection, and 3 points of intersection are given by 0 0, 0a and 0 minus a. Okay, so the curve are look like this type, this and this. The curve have two loops and two loops are symmetric because the curve is symmetric about x-axis and symmetric about y-axis. That is, the curve is same on the upper portion of x-axis and the lower portion of x-axis. Also, the curve is same in the left portion of y-axis and in the right portion of y-axis. Okay, and this is the origin, and this is a0, and this is b, this is minus a0. Now we have to find only the area of the half loop. Okay, then we multiply it by 4, we get the whole area of the curve. So whole area is given by 4 into integration. This is x equal to 0 to a, because here x equal to 0, here x equal to a, and this is y dx. Now what is the value of y? This is given by 0 to a. From this we get, this is 1 by a into root a square x to the power 4 minus x to the power 4. I think this is not x to the power 4, this is x square, right? So we put here x square and there be a dx. Okay, and this is 4 by a into integration 0 to a. We take common x and we get x square, a square minus x square dx. Now we put x equal to a sin theta and dx, this is equal to a cos theta d theta, right? And changing the range of integration from x to theta, we get this is 0 a and clearly this is 0 pi by 2. So we get 4 by a into integration 0 to pi by 2. Putting the value of x, this is a sin theta, and from here we get a square minus a square sin square theta, and from dx we get a cos theta d theta, and get the value as, from here we get a, we get also a, and we get here also a. So we taking common a cube, 0 to pi by 2, this is sin theta, this is cos theta, and this is also cos theta d theta. Okay, and this is given by 4 square into 0 to pi by 2, and this is sin theta into cos square theta d theta. Okay, now 4 square into integration 0 to pi by 2, this relation gives, and we also integrate this integration by putting sin theta equal to z. Okay, then we integrate it very easily. Then we get, sorry, this is not sin theta equal to z, this is cos theta equal to z. Then we get sin theta d theta, this is equal to dz. Okay, this is equal to dz here, and clearly the ranges are here, the range of theta, range of z. Range of theta is 0 pi by 2 and the range of z are 1 and 0. So we get, this is 1 and this is 0. We get sin theta d theta, this is equal to minus dz, we put minus dz, and cos theta equal to z, so we get z square. Now 4 square into integration 0 to 1 z square dz, and clearly by integrating this term we get 4 square by 3. Okay, and this is the second answer. 4 square by 3 is the whole area of the second curve. Okay, now go to the third curve. It is clear that if we put x greater than a, okay, then the right side is negative, or if we put x less than minus a, then also the left side is negative. Okay, because left side is a square, so we cannot take x greater than a and x less than minus a. Okay, otherwise y minus x is an imaginary number which is not real. So the range of integration must be from minus a to plus a. Okay, now it is clear that this is not symmetric about x-axis or y-axis, because it is not same if we put in place of y, if we put minus y, or if we put minus x in place of x. So this is not symmetric about x-axis and y-axis, but the curve lies must in minus a to a. So our integration, range of integration are from minus a to a. Okay, now from this curve we get two branch, y minus x, this is equal to plus minus root under a square minus x square. That is, we get y, this is equal to x plus minus root under a square minus x square. One branch from plus sign and one branch from minus sign, right? So we find out the total area of the curve, because here we require whole area. So the area of the curve is given by integration minus a to a y dx in the first line, but in the second line we here give a modular sign, and the first integration is integration minus a to a x plus root under x square minus a square dx, and in the second integration we get, this is also in modular sign, minus a to a, this is x minus root under x square minus a square into dx. Okay, now in the modular sign, the first integration, if we write this and this integration separately, then the first integration is a odd term integration. So as the problem number 2, we get the first integration is 0, and here only second integration is minus a to a root under x square minus a square dx. Also from the second term we get integration minus a to a, here also this is 0, and minus this is root under x square minus a square dx. Okay, here this integration is even function and this integrand also is even function. So using the property of even function, we get this integration is 0 to a 2 into root under x square minus a square dx, and from here we also get this is 2 into integration 0 to a, this is x square minus a square dx. Okay, but we make already a small mistake here. This is a square minus x square, so this is a square minus x square. So all the term are a square minus x square. Very sorry, this is a square minus x square. This is the same, a square minus x square. This is also a square minus x square, and this is same. Okay, and now both of them integration are like, so we get this is also 4 into integration 0 to a, and this is a square minus x square dx. And the formula of this integration we know, 4 into x into root under a square minus x square by 2 plus a square by 2 into sine inverse x by a, right? And the ranges are 0 to a. We get from the first term, by putting the value a and putting the value 0, both are 0. And from the second term we get a square by 2, putting a we get pi by 2, because this is sine inverse 1, and from the second or the lower range 0 we put in here 0, sine inverse 0 means 0. So we get the answer is 4 into a square pi by 4. 4 cancel out, that is pi square. Okay, so we get the answer pi square. This is the complete proof or complete solution of 3 problems. Okay, thank you for watching.